Hello, everybody. It is Tuesday, March 31st. This is day 2 of I can determine if a treatment is effective by seeing if the mean difference is outside the confidence interval. We said yesterday to determine if a treatment is effective, step 1 is we find the mean difference. Then we re-randomize everything. We look at our sample distribution. If our mean difference is outside the confidence interval, we shouldn't have gotten that randomly. Therefore, the treatment was effective. If the mean difference is inside the confidence interval of the random differences, then it's not effective because I would have gotten that value randomly without the treatment. So let's go over a few more like I said we would. Um, we'll take a look at 5. We'll take a look at 6. We'll take a look at 7. Maybe just 5 and 6. I'll let you try 7 on your own. All right, so let's move this to another page. Get my pen going. All right, to determine if the type of music played while taking a quiz has a relationship to results, 16 students were randomly assigned to either a room softly playing classical music or a room softly playing rap music. The results of the quiz were shown below. I guess my pen didn't want to work. So that's this data right here. John correctly rounded the difference of the means in his experimental groups as 7. So that's your mean difference. How did John obtain this value, and what does it represent? So let's use he found the mean of each group and subtracted them. And the mean difference, what it means is on average, because that's what mean is, on average, students in the classical group scored 7 points, since it's positive, higher than students in the rep group. To determine if there is any significance in this value, John re-randomized 16 scores into 2 groups of 8, calculated the mean differences, and simulated this process 250 times as shown below. So remember, the student scored 7 points higher in the classical group, but I don't know if that's significant or not. That might just be, if I randomly picked a group of students, maybe theirs is a little bit higher. So to determine if it's significant, I now re-randomize everything, and I look at the sample distribution. And if my mean difference of 7, so again, I'm just going to write that over here, my mean difference is 7. If my mean difference is outside the confidence interval or happens less than 5% of the time, then the treatment was effective and there's a significant difference. So 7 looks like it would be right here. So there are 4, 3 and 1. There's 4 values out of, I believe it said 250. So I need to know that percent. The magic number is 5. So if I go to my calculator and I divide those and make it into a percent, that's 0.016, which is 1.6%. The magic number is 5. If it's less than 5, then this is outside the confidence interval. So I shouldn't be outside the confidence interval. The reason I am outside the confidence interval is because the treatment was effective. There is a significant difference. So does the simulation support the theory? Yes. You can say 7 is outside the confidence interval. or you can say 7 occurred in less than 5% of the simulations. They both mean the same thing. Writing either one is fine. That's it. The math itself is pretty simple, but conceptually it is a little challenging. But once you get it, you get it. You find the mean difference. The mean difference it actually told you is 7. Then you re-randomize everything. You look at the sample distribution. If this value is outside the confidence interval, if it occurs less than 5% of the time, then yes, there's a significant difference. The treatment was effective because I shouldn't have gotten that value outside the confidence interval randomly. I got it because the treatment was effective. The treatment made it that much bigger of a difference. So we're going to go through one more. And then after that, I'll let you try 7 on your own, and you're going to have a quiz on this. And this is a common 4-point question in the readings. Gabriel performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants are planted without mulch. So his theory, his experiment, is to see if this black plastic mulch makes bigger tomatoes. He observed that the average weight of the tomatoes from the tomato plants grown in black plastic mulch was 5 ounces greater than those without. So your mean difference is 5. That's a really bad 5. That's better. To determine if the observed difference is statistically significant, that just means significant difference. If the treatment's effective, he re-randomized the tomato groups 100 times. His output is below. So 5 would fall right around here. So we're always looking out, because we're looking at this value and more extreme. Because if 5 is significant, then obviously 6 and 7 and 8, etc. are significant. So how many dots are there? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 34. If I counted wrong, it's no big deal. I kind of did it quick. 34 out of 100. That's 0.34. That's 34%. The magic number is 5%. If it's more than 5%, then it's inside the confidence interval. So, do you believe that planting in black plastic mulch causes larger tomato size? Was the treatment effective? No. 5 is inside the confidence interval. I would have gotten that randomly. The treatment didn't make this difference so significant that it would cause it to go outside the confidence interval. That's it. You can try number 7 on your own. Again, the answers, the key is all on Schlansky.com, password Tyler. You have a quiz on this. Just like any quiz, I don't know what to tell you. You have to do the lesson. You have to do the work. You can't just, pull up the quiz and expect to be able to do it. That's why, you have a teacher and we teach you things. So again, what you need to know is your classwork / homework is to finish evaluating treatments, mean differences, and then you have a quiz on mean differences to tonight. There's going to be one more lesson on statistics tomorrow, and then we're going to move on. Again, any questions, send me a message on Remind, email, I'm here for you.